What's up, math scholars and math haters? This is Mr. W. Today we're going to tackle question 11 of the 5th grade math questions that North Carolina released this past school year. The question tells us that a rectangular room is 12.5 feet long and 10.3 feet wide, and we're supposed to find the area of the room. So to do a question like this, and to do it really well, you need to know the area of a rectangle, and you also need to know how to multiply mixed numbers. There's two different methods for this that I'm going to go over, and there's also a trick answer that I definitely want to highlight here. So to start with, let's talk about the area of a rectangle. When we talk about the area of a rectangle, the area is just length, which I intentionally wrote right under the word long, times width, which I intentionally wrote under the word wide. So that means we're going to have to take 12.5 and multiply it by 10.3. Now there are two ways to do this, and I'm going to first do the way that should remind us most of the box method of multiplication, because that's essentially what it is. So with the box method of multiplication, if I were multiplying, for instance, 51 times 22, I would make a box out of 50 plus 1 and 20 plus 2. I'll make the box and I multiply 50 times 20, 50 times 2, 1 times 20, and 1 times 2. I'm going to do a very similar thing here. Let's see. I will make my box. I'll call this 12 plus 1/2 and 10 plus 1/3, and I wrote this the slanted way for the sake of space. But now I need to multiply and fill in each of these boxes. So now 12 times 10, let me use green for this. 12 times 10 is 120. 12 times 1/3, also known as 12 divided by 3, is 4. 10 times 1/2, also known as 10 divided by 2, is 5. And 1/3 times 1/2 is 1/6. So now I have to add 120 plus 5 plus 4 gets me 129 and 1/6, which, thank goodness, matches answer D. All right, so now I'm going to do this the other way. The other way is where I take each of my mixed numbers and I turn them into improper fractions. So I had to break out my bigger board in order to try the other method for solving question 11, which is to change our mixed numbers into improper fractions, multiply, and then simplify. Now this method doesn't involve using the box method, which if it's a little more, or if the box method is unfamiliar, this might be a little easier, but it also deals with doing some harder multiplication and even some harder simplification and division. So pick whichever method works best for you. I'm just going to go ahead and do this method right here because I said I was going to. So I'm going to start with my left to right swoosh method, where I multiply 2 times 12 and then add 1, and that gets me 25 halves, or 25 over 2. And I'm going to multiply this by, same trick, multiply and add. 3 times 10 is 30. 30 plus 1 is 31, which means that 10 1/3 is the same thing as 31/3, or 31 over 3. And now I can go ahead and multiply across my numerators and denominators. So I'm going to go ahead and do this multiplication problem the way that I know to do it, and with the box method. 25 times 31. The way that I know to do it, I start with 1 times 5, which is 5. 1 times 2 is 2. I essentially just multiply 25 by 1 to get 25. And now I get rid of this, and now it's kind of like I'm multiplying by 30, so I put a 0 down here to remind myself that I'm multiplying by a multiple of 10 and not just a number. So 3 times 5 is 15, also known as 5 ones and 1 10, or 5 tens and 1 100 if you want to think of it that way. 3 times 2 is 6 plus 7, so that's 25 plus 750, which gives us 775. So those are my numerators. For my denominators, 2 times 3 is just 6. So now I need to do a bit of dividing in order to change this from an improper fraction back to a mixed number. So I break out, and again, I'm going to do this division the way that I was taught. Actually, no, I said I would do box method for the multiplication. So here goes that. 20 plus 5, 30 plus 1. 20 times 30, same as 2 times 3, which is 6. And then we add 2 zeros. And then 30 times 5 is the same thing as 3 times 5, which is 15. And I add 1 0. 20 times 1 is 20. 1 times 5 is 5. 600 plus 150 plus 20 plus 5. That's 5 ones, 7 tens, and 700. So either way, we got 775. Our new improper fraction is 775 over 6, and now I have to turn that into a division problem. So now I have 775 divided by 6. First thing I'm going to do is I'm going to look at my hundreds digit and see how many times 6 goes into 7. 6 goes into 7 one time, so I'm going to take out that 6. 7 minus 6 is 1. And now I'm going to bring down my 7 because this represents the number of tens that I have left over now. And I'm going to see how many times 6 goes into 17. If I break out my 6 times table, that's 6, 12. Okay, 18 is too many. So 6 can go into 17 twice. Subtract 12 from that, and I just get 5 left over. I bring my 5 down, so now I'm looking at all my 1s that I have left. And I'm comparing 6 to 55, so if I keep this going, 24, 30, 36, 42, 48, 54, 60. I can get to 54, but anything above that, if I count by 6s, is going to be too many. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. 6 can go into 55 exactly, or not exactly, but 6 can go into 55 9 times. I subtract 54 from that, and I'm just left with 1. So this is another way of getting to that mixed number of 129 and 1/6. I even wrote out some of that work on this paper, but I did want to talk about the trick answer because I did want to talk about what would happen if you just multiplied 12 and 10, and if you just multiplied 1/2 and 1/3. 12 times 10 is 120. 1/2 times 1/3 is 1/6. So if you didn't know the box method or you didn't know this other method, the people who made this question would be expecting you to do 12 times 10, 1/2 times 1/3, and get 120 and 1/6 and think that you're done there. But you wouldn't be. That's the trick answer. The real answer is 129 and 1/6.